Next we'll study about the RMS value of current. Okay, RMS value of current, that you have studied in the electrical also. RMS value of current is denoted by IRMS, right? So what is RMS basically? Remember, that is root mean square. Okay, so basically what we want to calculate, we will calculate I square RMS. Okay, so I square RMS formula is again 1 by 2 pi. Limit starts from the 0 to 2 pi, and it would be I square RMS, so it would be I square d of omega t. Okay, so 1 by 2 pi as it is. Again we'll break the limit. As you know, this in the rectifier, our cycle breaks from 0 to pi and pi to 2 pi. Pi to 2 pi is always 0 in the half wave rectifier, so we'll not consider this case. This would be ultimately 0 only, so I'm considering this case only 0 to pi. Okay, so let the limit starts from 0 to pi. What is the standard equation for I? I is equal to, that is I max sine omega t d of omega t, right? So it is I square, so I max square, it is I square, so it would be sine square omega t, correct? Plus that limit would be 0 from pi to 2 pi, that would be 0 d omega t, because in that case there will be no output. So if we'll completely solve it, what will get answer? I'm not solving, but I'm telling you direct answer. If we'll solve it, then we'll get I square max divided by 4. That would be equal to I square RMS. But now we don't want I square RMS. What we want exactly? We want IRMS. Okay, so IRMS would be I max by 2. As you remember, in the electrical, what you have studied, IRMS would be I max by, remember, in electrical, RMS is equal to maximum divided by root 2. Okay, but now we have derived RMS is equal to maximum by 2. So this is the case of half wave rectifier, because we are getting half wave output for the positive one only, but this is will use for the full wave rectifier. So this is the standard will use for the full wave rectifier. This is the standard, but for the half wave rectifier we'll getting this formula, that IRMS is equal to Imax by 2 and for full wave by root 2. Okay, understood?